try to put it in the calculator. Okay, that's not a bad option, because if it crosses the x-axis, I can find out the solutions right away from the x-axis, and everything's good. But in this one, we now know that our answer should be imaginary. Okay, what would be the best way to solve this? What do you guys think? Number 9. Do we want to do the quadratic formula? No. Unless we really have to, right? I would agree. Okay. We could, right? Quadratic formula can be used on any quadratic equation. So we could do the quadratic formula, but if we don't have to, I agree. Let's not do it, right? So if we're not going to do the quadratic formula, then do we have any other way? You could take out the GCF. The only bad thing is that 28 doesn't have an x on it. So if I took out the GCF, it's now x squared plus 7. And that really hasn't helped us a ton.
We're trying
I know, yeah, no, it's a good thought though, and that is definitely one of the things that we talked about. There's nothing wrong with taking out the 4. So once I factor it, if the 4 had an x on it, then I would set it equal to 0, but the 4 doesn't have an x on it. So it doesn't really do any good to set 4 equal to 0. But I could do x squared plus 7 equals 0. Now, what do you think we could do? We haven't done this method a lot. That's why I'm talking to you about it here. If it's missing the b value in the middle, then one of the quick and easy ways that we could solve this is just to get x by itself. We could subtract 7. We could take the square root. Okay, don't forget the plus or minus, because whenever we do the square root method, we have to put plus or minus on our answers. And then how would I rewrite the square root of negative 7? I squared 7. Good. Because we're going to take out that negative. So my answer here would be plus or minus I radical 7. And the plus or minus is a really big deal here, because whenever we have an imaginary solution, then we always have 2 of them. So if you just said I radical 7, or the square root of negative 7, that would not be completely right. Okay, so the plus or minus is a big deal. Taking the I out is another thing. That's a really big deal. Okay, so that would be the quickest and easiest way. So if it's ever missing a b value, then you can do what we call the square root method. Okay, 13, it just says solve graphically. 14, you can solve that whatever method you want to do. I will give you a hint. That is another quadratic formula question, because if you graph that one, the answers are decimals. Okay, if the answers are decimals or i's, imaginary, and it says give the answer as an exact answer, then the decimals are not an exact answer. Okay, because the decimals go on forever, unless it was like 3.5. But this is not one of those decimals that stops. So that would be another one. Just giving you a helpful hint that even though it doesn't say solve by the quadratic formula, you're going to end up having to do the quadratic formula. So there's the second one you'll need the quadratic formula for. Okay, 15. We had a question like that on the quiz. Find the vertex. You can just do that in the calculator. Axis of symmetry. I'm going to show you on this one. Now, you could put this one into the calculator and graph it and find the vertex of it. But if you can remember this little formula, and the trick that I taught you last week is that if you cover up everything after the negative b on top, then negative b over 2a is the little formula that we use right here for the axis of symmetry. So you just get rid of the discriminant part, basically. My b value is 8, so this would become negative 8 over 2 times negative 3. Now the reason I'm showing this to you is because you could put this into the calculator, you could find the vertex, the x value of your vertex is my axis of symmetry, but in your calculator it's going to give it to you as a big long decimal. and it's a repeating decimal. So in this case here, this would be -8 over -6, which is 8 over 6, which is 4/3. Okay, so x equals 4/3 is our axis of symmetry. If you put it in the calculator, it's going to say like 1.3 repeating. And we don't really want to write 1.3 repeating. We really can't write 1.3 repeating. So there would be a reason why we want to use the formula. Okay, if my axis of symmetry happens to be a fraction. On number 17, just remember that the max or min is the y value of the vertex. So it's still another vertex question, but it's the y value of the vertex. 18 and 19 should be pretty straightforward. 18 is finding the vertex. They give you the graph. 19, what does the graph look like? They give you the equation, so that can just be plug it into the calculator and see what the graph looks like. Number 20 is kind of like the last one on the quiz last week, where there's 3 things I want you to do here. Okay, I want you to find the vertex. The vertex is an ordered pair. It also says to find the axis of symmetry. Whenever you write it, you always write it as x equals whatever. We kind of just talked about it, -b over 2a. Or, if I put this in my calculator, which is definitely the route I would go, once I get my vertex, the x value of the vertex is whatever the axis of symmetry should equal. So those two go hand in hand. Your vertex is going to end up being fractions or decimals here. So another thing that I'll kind of point out is that don't freak out if you get fractions or decimals for that. And then we also talked about identifying a couple of points. Just, obviously the vertex is going to be one of the points, and then a point probably on either side. So at least 3 points, the vertex, and a point on the right and a point on the left of the parabola. You don't necessarily have to put anything in the blank right here, but don't forget to graph it. A couple people did all the work, but then they forgot to graph it on the quiz. So make sure that you graph it and show me what the graph would look like, and use the points that you've come up with. 21 and 22, we saw some problems like that. On the quiz as well, what is the range of the graph? You can graph it, find out what the range is. It's your y values. The intervals, where is it increasing, decreasing? What we talked about last week is if the graph opens up, it's decreasing on the left, it's increasing on the right. If the graph opens down, it's increasing on the right or left and decreasing on the right. So it depends on if the graph opens up or down, depending on what your intervals would be. But make sure that you use the x values for your intervals. As I move from left to right, as my x values go from left to right, where is it increasing, where is it decreasing? Okay. 23, so this is what we did then on Thursday of last week. Rational functions, anytime we have a variable in the denominator. Let's go through, I'm going to kind of get you started on number 24. I'm going to let you finish it up, but just to kind of remember the things that we do. First of all, don't forget to look for restrictions. And what we mean by that is what values of x can x not equal. Most of the time, there will be restrictions because you have a variable in the denominator. Okay? And there might be more than one restriction in most cases. Before we can find those restrictions, we want to factor x squared minus 8x. So what could I do to factor x squared minus 8x? Take out an x, you bet. Just GCF. It's not DOPS because 8's not a perfect square. I'm just going to take out x, and it gives me x minus 8. So that replaces that. We're going to write it in factored form. So looking at those factors, what could I not put in for x right here? 0. And what about x minus 8? 8. Right? So those are my two restrictions. X cannot equal 0 or 8. When I do my next part, we're going to identify what the LCD is going to be. Anything that's on bottom at any point in time is part of my LCD. So that would be x and x minus 8. And how you do it from here is kind of up to you. What we talked about is to take that LCD and multiply each fraction by x and x minus 8. I like to write it in there. I know that I told you guys last week that some of you might feel like you can do it without writing it in there, and I'm okay with that, but just make sure you understand the process or what's going on. The reason I like to see it and write it out is so that I can physically see the things that I'm going to cross out. Okay? And I think you'll be a whole lot more successful if you do it that way. So for the first fraction, we can knock out the x minus 8s, and I take x times 8x, which is 8x squared. Okay, and then we got a minus sign in between. That's a really important thing, and we'll talk about why here in just in a second. And then my x's are going to cancel out. So I have 4 times x minus 8. And then over here, both x and x minus 8 are going to cross off, and all I'm left with here is 32. So as I start multiplying through, my fraction should be gone. And from here, then we just got to solve it. Okay. I'm going to let you guys finish it from there. I just wanted to kind of show you the steps, getting it set up and kind of getting it started. I'm going to let you finish it out. Number 23 is a little bit easier because there's no plus or minus signs. So on number 23, what would be my restriction? 0. X cannot be 0. There was no plus or minus sign, so that's my only restriction. What would be the LCD that I would use here? 6x. Good. So 6x is what I'm going to multiply all of the fractions by, all 4 fractions. Okay. So that one does not need plus or minus signs. Okay, 25 is very similar to what we just did. I will tell you the one thing that's a little different on 25. X squared minus 9, I can't do GCF because there is no GCF. How do I factor x squared minus 9? What does x squared minus 9 factor into?
X minus 9.
Yeah, good. It's good old Dobbs. X plus 3, x minus 3. And that just replaces that. Okay. And the good thing is what you'll notice, look at my other denominators, x minus 3 and x plus 3. So that would be my LCD, and then you can do your restrictions, LCD, and all that. Okay, so just a little bit different kind of factoring. Hey, on Thursday, we also talked about radical equations. You got one that's a square root. You got one that's a cube root. Be careful on 26. Whenever we have a square root, we got to watch out for when does the square root equal a negative. If the square root equals a negative, then it could be a no solution. So that's why no solution is a possibility there as you look at your multiple choice. Okay, and then on Friday, you have one of each type. We talked about absolute value equations and absolute value inequalities. So notice the answer here. This one, we're going to do 2 equations, but your answer is going to be x equals, and then you just identified the numbers that it's equal to. And remember that unless it's equal to 0, or if it's equal to a negative, then there would be no solution. But typically, you're going to end up with 2 answers when you do absolute value equations. A lot of times people forget that there's two answers there, and they'll just give me one of the two answers, but you gotta have two answers there most of the time. Okay, these two are the ones we talked about the trick. If it's less than, we think about less than. And so if I see a less than symbol, then this is gonna be an and statement when I do my two inequalities. And this one is greater than, so we think of great or, and we write or in between our two inequalities. So like this one here, we would say x plus 3 is greater than 2, or x plus 3 is less than negative 2. Write both of them out, solve them, graph it on the number line, that's why the number line's there, and then write your answer. Probably the easiest way to write the answer would be interval notation. I didn't say that you had to use interval notation here, and it's not multiple choice, so if you would rather write it a different way, I'm okay with that, but I think the way that I wrote it on my key is interval notation, and that's probably the quickest and easiest way to do it. Okay, questions so far you guys have? Okay, I'm gonna let you work. I did post answers this morning to 3, 4, 3, 5, so if you want to check those at some point today, you can do that.